Hi everyone. Today we are going to be talking about scientific notation. Now, in case you forgot what scientific notation is, or maybe you haven't learned it before, I'm going to be teaching it to you as if it's brand new. Now, the definition of scientific notation can be a little tricky. The definition states that in scientific notation, a number is written as a product of a coefficient and 10 raised to a power. That's just a fancy way of saying an example of scientific notation will have one number in front of a decimal point and it'll be multiplied by 10 raised to a certain exponent. The reason that we use scientific notation is to express really large and really small numbers in a simpler form. This way, instead of having it written all the way out and having to take up a lot of space, we can express it a lot more simplistically using scientific notation. Scientific notation also goes really well with a unit we call significant figures because you can change something that has a lot of significant figures and make it only have a few, but we'll talk about that later. So, the way that scientific notation works is that what you need is that one digit in front of the decimal point, and that digit can't be 0. So that means anything from 1 through 9, 1, 2, 3, 4, 5, 6, 7, 8, or 9 is going to be a number in front of the decimal point, and only one number. Then you are going to have to look at how many times you want to move that decimal point, because moving the decimal point is the same as multiplying or dividing by 10. And so if you look at this really large number here, we realize that the decimal point is located here. And in order to express it in scientific notation, we would need the decimal point to be located here right behind the 2. That means that you would have to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8 times to get the decimal point to be exactly behind the 2. And that would cause you to be essentially dividing this by 10 to the 8. So if you have a number that's 2.05, you're going to have to multiply it by 10 to the 8 in order to express it back like the original unit here, 205 million. Now, if I want to go the opposite way, I can as well. I need to move this decimal point so that it's behind the 3. Why the 3? Well, because I need one number in front of the decimal point that is not 0, and that's going to be the 3 because the 3 will be located in the ones column. So in order to do that, I need to move the decimal point 1, 2, 3, 4 times. That's going to cause me to have it right behind the 3. Okay? And in order to do that, how do I express 3.86? How do I get it back to this original number? Well, instead of using a positive exponent, I'll multiply it by a negative exponent, which will cause this decimal point to be moved in this direction. I'm essentially saying that I'm dividing this figure by 10 to the negative 4 in order to get this one. The really neat thing about scientific notation is you can always check if you're correct by plugging this whole value into your calculator, and if you are correct, you should get your original number. Same thing here. If this is your number and you think you did scientific notation correctly, then plug this entire value into the calculator and you should get your original number here. So now I want to show you a couple examples of me expressing some figures using scientific notation. Then we'll take a pause and I'll come back and talk to you about doing it in reverse. So here we have our first example. Now, if I wanted to express this in scientific notation, the first thing that I would need to do is move the decimal point. So how many times would I have to move the decimal point? Well, I want to make it so that I have only one number in the ones column. That means I would have to move the decimal point 1, 2, 3 times, which means I would now express this number as 5 times 10 to the, well, how many times did I move the decimal point? 1, 2, 3. 5 times 10 to the 3. However, this number is significantly smaller than 5. So if I were to try and change 5 back to the original value, I would need a negative coefficient. in order to make this smaller again. So this is going to be times 5 times 10 to the negative 3. Now let's look at this other example. I have 50.05. That means I'm going to need to move the decimal point to the left in this case, because that means that I'll only have one number in front of the decimal point. That'll be only one number in front or in the ones column. So in this case, I might express this as 5 decimal point, because I can only have one number in front of the decimal point, 0, 0, 5. And now I would still need to express it times 10 to a certain quantity. So let me write my times 10. And now it would be times 10 to the, well, how many times did I move it? I moved it once. I actually don't have to write it if it's just a 1, but I will because it's good practice. And here, if I do 5.005 times 10 to the 1, I will get this original value back. Now, this is an interesting one, 6.67. I only have one value in front of the decimal point, and it's in the ones column. So this is actually fine, but it's not in scientific notation, because if it was in scientific notation, I would still have to multiply it times 10 to a certain number. Well, we know that any number times 1 is itself. And so how would I multiply by 1 in this case? Well, that's actually 10 to the 0. 6.67 times 10 to the 0 gives me 6.67. But now this entire thing here is expressed in scientific notation. If you don't believe me, go ahead and plug it into your calculator. And lastly, they didn't give me a decimal point here. A lot of students struggle when they don't see the decimal point written. Sometimes they'll think, oh, well, maybe it's in lieu of the comma here or something like that. That's not the case. We know that decimal points are always written at the end. Even if they're not actually drawn in, they're implied that they're at the end. So the decimal point would be here behind the 8, even if it wasn't written. And so if I wanted to express this in scientific notation, I would need to show you only one number in front of the decimal place, only decimal point, I should say, and I should have only one digit in the ones place, or the ones column. So how many times would I have to move the decimal point in order to make that happen? 1, 2, 3. I would need to move it 3 times. I would rewrite it as 7.008, and I would have to express that times 10 to a certain exponent. Well, how do I know? Well, how many times did I move that decimal point? 1, 2, 3. So that really means that I'm multiplying by 10 to the 3. Okay? 10 to the 3 is really just another way of expressing 1,000, because if we have 10 to the 0 is 1, and 10 to the 1 is 10, then 10 to the 2 is 100, and then 10 to the 3 would be 1,000. So I'm really saying 7.008 times 10 to the 3, which is times 1,000. Let me get that comma in there. That's a very sloppy comma. And so if I were to multiply 7.008 times 10 to the 3, or times 1,000, I would move that decimal point and I would get 7,008. Practice taking numbers and putting them into scientific notation. I want to go ahead and take numbers that are in scientific notation and write them as they would normally be expressed. So here we have a number 1.5 times 10 to the 3. And we want to put it into expanded form. We want to take this and make it what you might call a normal number, a number that's not in scientific notation. We call it standard form, or expanded form, rather. And so now let's look. We got a 3 here. Well, the 3 is clearly going to make this bigger. That's 1,000 that I'm multiplying it by. I have to move this decimal point. 1, 2, 3 times to the right, filling that in with zeros. And so while it's tough to see here, if I rewrite it here, I have 1,500 because I have moved the decimal place 3 to the right. Okay. Now let's look at this one. Now we have a negative sign here. So that means I'm actually going to be dividing, and in this case, by 10 to the negative 4 or 10,000. So I'm actually going to be moving the decimal point to the left when I see a negative here, and I'm in scientific notation. That's 2, 3, and 4. I'm going to put my decimal point here. I'm going to fill that in. Let's see how many zeros that's going to wind up being in front. That's 3 zeros in front of the 7 and behind the decimal point. So that's going to be equal to 0.00703. And forgive my sloppiness, I am writing this on a laptop. Some people will put a 0 out in front here. It is the exact same thing because you'll notice these 3 zeros come after the decimal point once I've put it into expanded notation. Okay, and here our final one. I thought it might be neat for us to do essentially the same figure, but the only difference being that the first one here does not have a negative symbol and this one does. So in this case, I'm going to move the decimal point to the right because I'm essentially multiplying by 10 to the 6. Which should be a million. 1, 2, 3, 4, 5, 6. I'm going to fill in those 2 extra spots with zeros. Okay. And so that's going to give me 6, 0, 0, 0, 8. And then don't forget about these 2 additional zeros. 0, 0. If I were to write that out, put my commas in for every 3. It's going to be 6,800,000. And now the last one, we're actually going in the opposite direction. Because of this negative sign, I'm dividing by a million. And so in this case, I'm going to go, okay, let's count. 1, 2, 3, 4, 5, 6. Put the decimal point here. Fill this with zeros. 1, 2, 3, 4, 5 zeros. And then if I were to rewrite it, I'm getting smart. If I were to rewrite it, I would rewrite it as 6, or rather, I would write it as 0.12345. I don't need this 0 here. These 1, 2, 3, 4, 5 zeros are the ones located here. I do then need, of course, the 6, then 3 more zeros, 1, 2, 3, and then an 8. And now I'll just expand this text box in order to fit our final answer. So that's how you take numbers that are written in scientific notation and write them in expanded form. Sorry, I apologize that some of these are a little sloppy. Hopefully I made it up to you here by typing it into the text box. If you have any questions, we'll go over this again in class, not to worry, and I'll see you soon.